Battleship in Python. First of all, we have to import this statement in order to invoke the important machinery for for the code. We imported datetime, the random for random numbers, and the matplotlib for graphs. Then we printed all instructions in order to make it easier for the user to play the game. Then we go to the register, which we have an input for each player, for player A and player B. They write their names and they are inside the game. Then we have an empty list for players. And we generate the turns for each player, where turn 1 has to be, if it's bigger than 0.5, player A will be player 1 and player B will be player 2. And we append it into the variable that we state before. And if not, well, A will print that player B is player 1 and player A is player 2, and we append it into our variables at the beginning.
Well, then we do an empty list called table that in this for, we will introduce the elements of that list, and we will do the board game in which we will put the votes. Then this for is for the 2 players. First, it will print the player 1, that in this case is Danny, and we will print the list of votes that she can put in the game board. Then it will select the vote, and this value error will check that all the possible errors like this. I can put an A, and it will print not valid, enter, try again. I can put a double element, and it will print again that part. Also, they need to be in the range of these numbers, 0 to 4. If I put 5, it will print not valid vote because we do not have a 5th vote. So I will press the vote 0, that is the carrier, that it has 5 coordinates. And I will put the first coordinates here. This 4 will be in the length of the list of votes that we will have. When we choose a vote, like here, I choose the carrier, it will eliminate of the list of votes in this part, and then we'll break and pass to the other while. In this while, it will join the table, it will print the game board, and it will ask the position in X axis, that for us is the rows, and I will put the first number. Also here, it will check the possible errors that we can commit, like in the past input. And here I will put the first coordinates. The columns are in the J axis, and I will put 9, that is here. Then it will choose the orientation, if it's vertical or horizontal, that is this part of the code. And we'll check also the possible errors. I will choose horizontal to the left, and it will put the vote in with the letter B's, and the number of B's that they will put in the board is the number of coordinates that we will have from each vote. Here, if I put a vertical, it also will work. But for example, if I choose the Battleship and I will put in 0, 0, that is here, and I choose vertical upward, it will say that the vote need to be in the game board, because I put the vote upward like this, and it will not be in the game board. So I need to put another coordinates like vertical downwards, and it will put the vote in the place because it's in the board. And in each turn, it will eliminate one vote at a time. So I will put the next 3 votes that I think I need. So it's 5,5 horizontal to the left. This is the third vote, and I need another 2. The submarine, I will put 9,0. I horizontal to the left, and it will say that the board also I have an error, so I will put 9,0, that is here, vertical, upward, and the last vote is in 2.2, that it only have one coordinate. When the first player put all its votes, it will print this matrix that is here, no, here, and then the second player will choose its votes to play.
In this part, we have several counters that will be good points for player 1, good points for player 2, total turns that it's for both, turns for player 1 and for player 2, and bad points for player 1 and player 2. Then we have a 2 list that is turn 1 and turn 2, and another 2 counters that are consecutive of player 1 and consecutive of player 2. Then we have another counter that is k equal to 0. The loop here basically says that first you start with 15 possible shots. If you shot it, you will have an ad. And if you have an ad, a possible shot will be one less possible shot will be, so instead of 15, you will end up with 14 possible shots. Once you get to 0, it means that you are the player and the loop breaks. First, we have here k equal to 0. So it doesn't go into here. It means that, for example, here, you have to select the player. And how did we select the player? We made this k equal to 0. Once k equal to 0, for example here, it will be referred to the player 1. Here, table and 0, it will be referred to the player 1. So it's the player 1's turn. So at the end, it will be added a total turn. Then you will be asked to place your shot in the X, that it will be our rows, and Y, that will be our columns. So in order for this game to function, we made this, that if it's not in the range, for example in X, that it's our row, if it's not in range of 10, that is the size of our matrix, it will print you must shot within the limits 0 to 9, in case the player didn't read the instructions. The same for the Y, that it's our columns. For example, if I put here you must shot within the limit 0 to 9. So it's still Danny's turn. Why is it still Danny's turn? Because in order to change the player, you must complete the loop in 2 ways. 1, you miss the shot, or 2, or the second, you shot it. If you shot it, it will remain your turn. Once you miss the shot, it will go to the other player. It will be the player 2 turn. So in here, the k will be 1. It will be added 1. Once you miss the shot, it's the only case you can change the players. So in here, k equal to 1. If k equal to 1, it will be referred to the table 1. So it will be players 2. If it's player 2, you start from the beginning. In the first round, you have 15 possible shots, and if you go to 0, you are the winner. Then in here, it's basically the same. You will be asked the X and Y columns, and if you missed or you place the shot in a place that has already been shot by you, it won't change. It will be your turn until you miss the shot or you shot it, and if you shot it, it's once again your turn until you miss that shot. Once you miss that shot, it will be like a bad point for you, well, for the player, and if you shot it, it will be a good point. If it's a good point, then our consecutive counter will be incrementing, will be added 1. For example, we started with consecutive player 2 equal to 1 and consecutive player 1 equal to 1. If you shot it, then you add 1. If you add 1, you have like a streak. Once you break that streak, you pass the turn to the other player, and the other player can make all the points if all the points they want. Once they miss the shot, it's your turn again. So that's why we put this one, because it was very difficult for us to change the players. So if it's 1, it's referred to the player 2. Then if the player 2 missed the shot, it will be added 1. So K will be 2 instead of 1. If K equals 2 in here, it will be 0 again. If it's 0 again, it's referred to the player 1 again. And that's the dynamic for this part. We placed the shots. And for example, in here, the player shot 5,8. So it will be 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5, 6, 7, 8. So there, and Alan missed the shot. So it's Danny's turn because K was added 1. So it's now Alan's turn. For example, in here, Alan shot in 6,8, and it was a good shot. So it remains Danny's turn. And until there is no more votes, or until the possible shots are equal to 0.
The last part of the program, after it gave us the winner and the loser, is the graphing part, and the program is going to display 5 charts. The first and the second charts are pie charts. There is a comparison of successful against unsuccessful attacks for each player by percentage. The blue part is representing the good points or the successful attacks. Meanwhile, the orange part are the percentage of bad points or unsuccessful attacks. This is for each player, as we can see in the image, like player 1 and player 2. The part of the code that is displaying the charts tells us line by line what we want in each graph, from the title and color to percentage, as we can see here. And it also tells us the labels that we want to represent in the graph. The third graph is a bar chart, and it is a comparison of the progress of each player, representing by turns in blue part and good points in orange part. The x-axis shows each player, player 1 and player 2, and the y-axis represents the games of all around the game. The part of the code that is displaying this chart, line by line, is giving the structure of the chart from title and color to each name of the axis and what we want to represent, as we can see here. The last two charts are histograms, and that is representing the frequency of how many attacks or times each player gave. For example, here, for each player, progress of player 1, progress of player 2, and the x-axis represent the consecutive turns, and the y-axis represent the frequency. The graphs, thanks to the function that is at the beginning of the code, which is import datetime, are going to be saved in the desktop with the exactly time and date that the game is finished. Each graph in the code has a line which is going to save the chart in image format, and I mean that JPG, as we can see here. In the line 278, it's going to plot like the histograms. In the line 262, it's going to display the bar chart, and for the pie charts, it's going to be in the line 247 and 238. And at the end, the desktop will show us the graphs that is saved with the date and the time of the game. And that's all for the game.